Brought to you by WikiVD Documentaries. Boeing 787 Dreamliner. The Boeing 787 Dreamliner is an American long-haul, mid-size wide-body, twin-engine jet airliner made by Boeing Commercial Airplanes. Its variants seat 242 to 335 passengers in typical three-class seating configurations. It is a pioneering airliner, with the use of composite materials as the primary material in the construction of its airframe. The 787 was designed to be 20% more fuel efficient than the Boeing 767, which it was intended to replace. The 787 Dreamliner's distinguishing features include mostly electrical flight systems, raked wingtips, and noise-reducing chevrons on its engine nacelles. It shares a common type rating with the larger Boeing 777 to allow qualified pilots to operate both models. The aircraft's initial designation was the 7E7, prior to its renaming in January 2005. The first 787 was unveiled in a rollout ceremony on July 8, 2007 at Boeing's Everett factory. Development and production of the 787 has involved a large-scale collaboration with numerous suppliers worldwide. Final assembly takes place at the Boeing Everett factory in Everett, Washington, and at the Boeing South Carolina factory in North Charleston, South Carolina. Originally planned to enter service in May 2008, the project experienced multiple delays. The airliner's maiden flight took place on December 15, 2009, and completed flight testing in mid-2011. Boeing has reportedly spent $32 billion on the 787 program. Final U.S. Federal Aviation Administration and European Aviation Safety Agency type certification was received in August 2011, and the first 787-8 was delivered in September 2011. It entered commercial service on October 26, 2011 with launch customer All Nippon Airways. The stretched 787-9 variant, which is longer and can fly farther than the 8, first flew in September 2013. Deliveries of the 787-9 began in July 2014. It entered commercial service on August 7, 2014 with All Nippon Airways, with 787-9 launch customer Air New Zealand following 2 days later. As of May 2017, the 787 had orders for 1223 aircraft from 65 customers, with All Nippon Airways having the largest number on order. The aircraft has suffered from several in-service problems, including fires on board related to its lithium-ion batteries. These systems were reviewed by both the FAA and the Japan Civil Aviation Bureau. The FAA issued a directive in January 2013 that grounded all 787s in the U.S., and other civil aviation authorities followed suit. After Boeing completed tests on a revised battery design, the FAA approved the revised design and lifted the grounding in April 2013. The 787 returned to passenger service later that month. Background. During the late 1990s, Boeing considered replacement aircraft programs as sales of the 767 and 747,400 slowed. Two new aircraft were proposed, the 747X, which would have lengthened the 747,400 and improved efficiency, and the Sonic Cruiser, which would have achieved 15% higher speeds while burning fuel at the same rate as the 767. Market interest for the 747X was tepid, however several major American airlines including Continental Airlines, showed initial enthusiasm for the Sonic Cruiser, although concerns about the operating cost were also expressed. The global airline market was disrupted by the September 11, 2001 attacks and increased petroleum prices, making airlines more interested in efficiency than speed. The worst affected airlines, those in the United States, had been considered the most likely customers of the Sonic Cruiser. Thus the Sonic Cruiser was officially cancelled on December 20, 2002. On January 29, 2003, Boeing announced an alternative product, the 787. Using Sonic Cruiser technology in a more conventional configuration. The emphasis on a smaller mid-size twin-jet rather than a large 747-size aircraft represented a shift from hub-and-spoke theory towards the point-to-point theory, in response to analysis of focus groups. For Boeing Commercial Airplanes VP Marketing Randy Basler, airport congestion comes from a large numbers of regional jets and small single aisles, flying to destinations where a 550-seat A380 would be too large, to reduce the number of departures. Smaller airplanes can increase 20% in size and airline hubs can be avoided with point-to-point transit. The replacement for the Sonic Cruiser project was named 787. Technology from the Sonic Cruiser and 787 was to be used as part of Boeing's project to replace its entire airliner product line, an endeavor called the Yellowstone Project. Early concept images of the 787 included rakish cockpit windows, a dropped nose and a distinctive shark fin tail. The E was said to stand for various things, such as efficiency or environmentally friendly. However, in the end, Boeing said that it merely stood for 8. In July 2003, a public naming competition was held for the 787, for which out of 500,000 votes cast online the winning title was Dreamliner. Other names included Airliner, Global Cruiser, and Stratoclimber. On April 26, 2004, Japanese airline All Nippon Airways became the launch customer for the 787, announcing a firm order for 50 aircraft with deliveries to begin in late 2008. The ANA order was initially specified as 30787-3, 290,330-seat, 1-class domestic aircraft, and 20787-8, long-haul, 210,250-seat, 2-class aircraft. For regional international routes such as Tokyo, Narita, Beijing, and could perform routes to cities not previously served, such as Denver, Moscow, and New Delhi. The 787-3 and 787-8 were to be the initial variants, with the 787-9 entering service in 2010. The 787 was designed to be the first production airliner, with the fuselage comprising one-piece composite barrel sections instead of the multiple aluminum sheets and some 50,000 fasteners used on existing aircraft. Boeing selected 2 new engines to power the 787, the Rolls-Royce Trent 1000 and General Electric Gen X. Boeing stated the 787 would be approximately 20% more fuel efficient than the 767, with approximately 40% of the efficiency gain from the engines, plus gains from aerodynamic improvements, increased use of lighter-weight composite materials, and advanced systems. The airframe underwent extensive structural testing during its design. The 787-8 and -9 were intended to have a certified 330-minute ETOPS capability. During the design phase, the 787 underwent extensive wind tunnel testing. At Boeing's transonic wind tunnel, Kinetics 5-meter wind tunnel at Farnborough, United Kingdom, and NASA Ames Research Centre's wind tunnel, as well as at the French Aerodynamics Research Agency, ONERA. The final styling was more conservative than earlier proposals, with the fin, nose, and cockpit windows changed to a more conventional form. By 2005, customer announced orders and commitments for the 787 reached 237 aircraft. Boeing initially priced the 787-8 variant at $120 million, a low figure that surprised the industry. In 2007, the list price was $146,151.5 million for the 787-3, $157,167 million for the 787-8, and $189,200 million for the 787-9. Manufacturing and suppliers. On December 16, 2003, Boeing announced that the 787 would be assembled in its factory in Everett, Washington, instead of conventionally building the aircraft from the ground up. Final assembly employed 800 to 1,200 people to join completed sub-assemblies and to integrate systems. Boeing assigned global subcontractors to do more assembly work, delivering completed sub-assemblies to Boeing for final assembly. This approach was intended to result in a leaner, simpler assembly line and lower inventory, with pre-installed systems reducing final assembly time by 3/4 to 3 days. Subcontractors had early difficulties procuring needed parts and finishing sub-assemblies on schedule, leaving remaining assembly work for Boeing to complete as traveled work. In 2010, Boeing considered in-house construction of the 787-9 tail. The tail of the 787-8 is made by Airliner. The 787 was unprofitable for some subcontractors. Airliner's parent company, Finmeccanicam, had a total loss of €750 million on the project by 2013. Subcontracted assemblies included wing manufacture, horizontal stabilizers, fuselage sections, passenger doors, cargo doors, access doors, and crew escape door, software development, floor beams, wiring, wingtips, flap support fairings, wheel well bulkhead, and longerons, landing gear, and power distribution and management systems, air conditioning packs. To speed up deliveries, Boeing modified 4 used 747-400s into 747 Dreamlifters to transport 787 wings, fuselage sections, and other smaller parts. Japanese industrial participation was key on the project. Japanese companies co-designed and built 35% of the aircraft, the first time that outside firms played a key design role on Boeing airliner wings. The Japanese government supported development with an estimated $2 billion in loans. On April 26, 2006, Japanese manufacturer Toray Industries and Boeing signed a production agreement involving $6 billion worth of carbon fiber, extending a 2004 contract. In May 2007, final assembly on the first 787 began at Everett. Boeing worked to trim excess weight since assembly of the first airframe began in late 2006. The first 6 787s were stated to be overweight, with the first aircraft being heavier than specified. The seventh and subsequent aircraft would be the first optimized 787-8 as expected to meet all goals. Accordingly, some parts were redesigned to include more use of titanium. Early-built 787s were overweight and some carriers decided to take the later aircraft. In early 2015, Boeing was trying to sell 10 such aircraft. In July 2015, Reuters reported that Boeing was considering reducing the use of titanium to reduce construction costs. Boeing intended for a first flight by the end of August 2007, and premiered the first 787 at a rollout ceremony on July 8, 2007. The 787 had 677 orders at this time, which is more orders from launch to rollout than any previous wide-body airliner. The major systems were not installed at the time. Many parts were attached with temporary non-aerospace fasteners requiring replacement with flight fasteners later. In September 2007, Boeing announced a 3-month delay, blaming a shortage of fasteners as well as incomplete software. On October 10, 2007, a second 3-month delay to the first flight and a 6-month delay to first deliveries was announced due to supply chain problems, a lack of documentation from overseas suppliers, and flight guidance software delays. Less than a week later, Mike Baer, the 787 program manager, was replaced. On January 16, 2008, Boeing announced a third 3-month delay to the first flight of the 787. Citing insufficient progress on traveled work. On March 28, 2008, in an effort to gain more control over the supply chain, Boeing announced plans to buy Vought Aircraft Industries' interest in Global Aeronautica. A later agreement was also made to buy Vaught's factory in North Charleston. On April 9, 2008, a fourth delay was announced, shifting the maiden flight to the fourth quarter of 2008, and delaying initial deliveries by around 15 months to the third quarter of 2009. The 787-9 variant was postponed to 2012, and the 787-3 variant was to follow at a later date. On November 4, 2008, a fifth delay was announced due to incorrect fastener installation and the Boeing machinists' strike, stating that the first test flight would not occur in the fourth quarter of 2008. After assessing the program schedule with suppliers, in December 2008, Boeing stated that the first flight was delayed until the second quarter of 2009. Airlines such as United Airlines and Air India stated their intentions to seek compensation from Boeing for the delays. Pre-flight ground testing. As Boeing worked with its suppliers towards production, the design proceeded through a series of test goals. On August 23, 2007, a crash test involving a vertical drop of a partial composite fuselage section from the bow onto a thick steel plate occurred in Mesa, Arizona. The results matched predictions, allowing modeling of various crash scenarios using computational analysis instead of further physical tests. While critics had expressed concerns that a composite fuselage could shatter and burn with toxic fumes during crash landings, test data indicated no greater toxicity than conventional metal airframes. The crash test was the third in a series of demonstrations conducted to match FAA requirements, including additional certification criteria due to the wide-scale use of composite materials. The 787 meets the FAA's requirement that passengers have at least as good a chance of surviving a crash landing as they would with current metal airliners. On August 7, 2007, on-time certification of the Rolls-Royce Trent 1000 engine by European and U.S. regulators was received. The alternative GE Gen X-1B engine achieved certification on March 31, 2008. On June 20, 2008, the first aircraft was powered up, for testing the electrical supply and distribution systems. A non-flight-worthy static test airframe was built on September 27, 2008. The fuselage was successfully tested at 14.9 side differential, which is 150% of the maximum pressure expected in commercial service. In December 2008, the 787's maintenance program was passed by the FAA. On May 3, 2009, the first test 787 was moved to the flight line following extensive factory testing, including landing gear swings, systems integration verification, and a total run-through of the first flight. On May 4, 2009, a press report indicated a 10–15% range reduction, about instead of the originally promised 7,700 to 8,200 nmi, for early aircraft that were about 8% overweight. Substantial redesign work was expected to correct this, which would complicate increases in production rates. Boeing stated the early 787-8s would have a range of almost. As a result, some airlines reportedly delayed deliveries of 787s in order to take later planes that may be closer to the original estimates. Boeing expected to have the weight issues addressed by the 21st production model. On June 15, 2009, during the Paris Air Show, Boeing said that the 787 would make its first flight within 2 weeks. However, on June 23, 2009, the first flight was postponed due to structural reasons. Boeing provided an updated 787 schedule on August 27, 2009, with the first flight planned to occur by the end of 2009 and deliveries to begin at the end of 2010. The company expected to write off $2.5 billion because it considered the first 3 Dreamliners built unsellable and suitable only for flight tests. On October 28, 2009, Boeing selected Charleston, South Carolina as the site for a second 787 production line after soliciting bids from multiple states. On December 12, 2009, the first 787 completed high-speed taxi tests, the last major step before flight. Flight Test Program. On December 15, 2009, Boeing conducted the 787-8 maiden flight from Payne Field in Everett, Washington, at 10:27 a.m. PST and landed 3 hours later at 1:33 p.m. at Seattle's Boeing Field. After reaching and originally scheduled for 5.5 hours, the test flight was shortened to 3 hours, with the pilots wanting to complete the flight under visual meteorological conditions while visibility and cloud ceiling were low. The 6800H-6 aircraft ground and flight test program was scheduled in 8.5 months. The fastest certification campaign for a new Boeing commercial design. The flight test program comprised 6 aircraft, ZA001 through ZA006, 4 with Rolls-Royce Trent 1000 engines and 2 with GE Gen X-1B64 engines. The second 787, ZA002 in all Nippon Airways livery, flew to Boeing Field on December 22, 2009. To join the flight test program, the third 787, ZA004 made its first flight on February 24, 2010. Followed by ZA003 on March 14, 2010. On March 24, 2010, flutter and ground effects testing was completed, clearing the aircraft to fly its entire flight envelope. On March 28, 2010, the 787 completed the ultimate wing load test. which requires that the wings of a fully assembled aircraft be loaded to 150% of design limit load, and held for 3 seconds. The wings were flexed approximately upward during the test. Unlike past aircraft, the wings were not tested to failure. On April 7, data showed the test had been a success. On April 23, 2010, the newest 787 ZAOO-3 arrived at the McKinley Climatic Laboratory hangar at Eglin Air Force Base, Florida, for extreme weather testing in temperatures ranging from, including takeoff preparations, at both temperature extremes. ZAOO-5, the fifth 787 and the first with Gen X engines, began ground engine tests in May 2010, and made its first flight on June 16, 2010. In June 2010, gaps were discovered in the horizontal stabilizers of test aircraft due to improperly installed shims. All aircraft were inspected and repaired. That same month, a 787 experienced its first in-flight lightning strike. Inspections found no damage, as composites can have as little as 1/1000th the electrical conductivity of aluminum. Conductive material is added to ameliorate potential risks and to meet FAA requirements. The FAA also planned requirement changes to help the 787 show compliance. The 787 made its first appearance at an international airshow at the Farnborough Airshow, United Kingdom, on July 18, 2010. On August 2, 2010, a Trent 1000 engine suffered a blowout at Rolls-Royce's test facility during ground testing. The failure due to the timeline for installing Trent 1000 engines being re-evaluated. On August 27, 2010, Boeing stated that the first delivery to launch customer ANA would be delayed until early 2011. That same month, Boeing faced compensation claims from airlines owing to ongoing delivery delays. In September 2010, it was reported that a further 2 787s might join the test fleet, for a total of 8 flight test aircraft. On September 10, 2010, a partial engine surge occurred in a Trent engine on ZAOO-1 at Roswell. On October 4, 2010, the 6th 787 ZAOO-6 joined the test program with its first flight. On November 9, 2010, Boeing 787 ZAOO-2 made an emergency landing at Laredo International Airport, Texas, after smoke and flames were detected in the main cabin during a test flight. The electrical fire caused some systems to fail before landing. Following this incident, Boeing suspended flight testing on November 10, 2010. Ground testing continued. After investigation, the in-flight fire was primarily attributed to foreign object debris that was present in the electrical bay. After electrical system and software changes, the 787 resumed flight testing on December 23, 2010. On November 5, 2010, it was reported that some 787 deliveries would be delayed to address problems found during flight testing. In January 2011, the first 787 delivery was rescheduled to the third quarter of 2011 due to software and electrical updates following the in-flight fire. By February 24, 2011, the 787 had completed 80% of the test conditions for Rolls-Royce Trent 1000 engine and 60% of the conditions for the General Electric Gen X-1B engine. In July 2011, ANA performed a week of operations testing using a 787 in Japan. The test aircraft had flown 4,828 hours in 1707 flights combined by August 15, 2011. During testing, the 787 visited 14 countries in Asia, Europe, North America, and South America to test in extreme climates and conditions and for route testing. On August 13, 2011, certification testing of the Rolls-Royce-powered 787-8 finished. The FAA and European Aviation Safety Agency certified the 787 on August 26, 2011, at a ceremony in Everett, Washington. Certification had taken 18 months, twice as long as originally planned. The newer stretched version, 787-9, had flown 141 hours as of November 8, 2013. Service entry and early operations. Certification cleared the way for deliveries. In 2011, Boeing prepared to increase 787 production rates from 2 to 10 aircraft per month at assembly lines in Everett and Charleston over 2 years. Legal difficulties clouded production at Charleston. On April 20, 2011, the National Labor Relations Board alleged that a second production line in South Carolina violated 2 sections of the National Labor Relations Act. In December 2011, the National Labor Relations Board dropped its lawsuit after the Machinists' Union withdrew its complaint as part of a new contract with Boeing. The first 787 assembled at South Carolina was rolled out on April 27, 2012. The first 787 was officially delivered to All Nippon Airways on September 25, 2011, at the Boeing factory. A ceremony to mark the occasion was also held the next day. On September 27, it flew to Tokyo Haneda Airport. The airline took delivery of the second 787 on October 13, 2011. On October 26, 2011, an ANA 787 flew the first commercial flight from Tokyo Narita to Hong Kong. The airliner was planned to enter service some 3 years prior. Tickets for the flight were sold in an online auction. The highest bidder had paid $34,000 for a seat. An ANA 787 flew the first commercial long-haul flight on January 21, 2012 from Haneda to Frankfurt. On December 6, 2011, test aircraft ZA006, powered by General Electric Gen X engines, flew non-stop from Boeing Field eastward to Shah Jalal International Airport in Dhaka, Bangladesh, setting a new world distance record for aircraft in the 787's weight class, which is between. This flight surpassed the previous record set in 2002 by an Airbus A330. The Dreamliner then continued eastbound from Dhaka to return to Boeing Field, setting a world-circling speed record of 42 hours, 27 minutes. In April 2012, an ANA 787 made a delivery flight from Boeing Field to Haneda Airport, partially using biofuel from cooking oil. In 2011, Boeing conducted a promotion 787 World Tour, visiting various cities in China, Africa, the Middle East, Europe, United States, and others. According to ANA data, the 787 surpassed the promised 20% fuel burn reduction comparison to the 767, achieving a 21% fuel saving on the Tokyo-Frankfurt route. ANA surveyed 800 passengers who flew the 787 from Tokyo to Frankfurt. Expectations were surpassed. For 90% of passengers, features that met or exceeded expectations included air quality and cabin pressure, cabin ambience, higher cabin humidity levels, headroom, and the larger windows. 25% said they would go out of their way to again fly on the 787. Other 787 operators have reported similar fuel savings, ranging from 20–22% compared with the 767-300ER. An analysis by consulting firm Air Insight concluded that United Airlines 787s achieved an operating cost per seat that was 6% lower than the Airbus A330. Early operators discovered that if the APS 5000 APU was shut down with the inlet door closed, heat continued to build up in the tail compartment and cause the rotor shaft to bow. It could take up to 2 hours for the shaft to straighten again. This was particularly acute on short-haul flights as there was insufficient time to allow the unit to cool before a restart was needed. Procedures were modified and the APU was later redesigned to address the issue. On September 15, 2012, the NTSB requested the grounding of certain 787s due to GE engine failures. GE believed the production problem had been fixed by that time. In March 2014, Mitsubishi Heavy Industries informed Boeing of a new problem that was caused by a change in manufacturing processes. Employees did not fill gaps with shims to connect wing rib aluminum shear ties to the carbon composite wing panels. The tightened fasteners, without shims, cause excessive stress that creates hairline cracks in the wings, which could enlarge and cause further damage. 42 aircraft awaiting delivery were affected, and each one required 1–2 weeks to inspect and repair. However, Boeing did not expect this problem to affect the overall delivery schedule, even if some airplanes were delivered late. Dispatch reliability is an industry-standard measure of the rate of departure from the gate, with no more than 15 minutes delay due to technical issues. The 787-8 started out with approximately 96% operational reliability, increasing to approximately 98.5% in April 2015. Daily utilization increased from 5 hours in 2013 to 12 hours in 2014. Dispatch reliability grew to 99.3% in 2017. Airlines have often assigned the 787 to routes previously flown by larger aircraft that could not return a profit. For example, Air Canada offered a Toronto to New Delhi route, first utilizing a Lockheed L1011, then a Boeing 747, then an Airbus A340, but none of these types were efficient enough to generate profit. The airline operated the route profitably with a 787-9, and credits the right number of seats and greater fuel efficiency for this success. Thank you for watching. Brought to you by WikiVidi Documentaries. Please like and subscribe below. Please like and subscribe below.